Evening, students. Today we will discuss about network models. Actually, the network models is based on the network. So, in the operations research, we have the network model. In the network model, we have the basic definition. So, the first one is vertices and edges. So, what is a spanning tree? But in this network model, we have spanning tree, a minimum spanning tree, and so on. So, what is spanning tree? Given an undirected and connected graph, G equal to V comma E. Here V means vertex and E means edges. Therefore, the graph G equal to V comma E. A spanning tree of the graph G. Here G is a tree that spans GC, that is including every vertex of the graph and its subgraph is known as spanning tree, right? So what is the minimum spanning tree? So here the minimum spanning tree is nothing but the cost of spanning tree is the sum of the weights of all the edges in the tree. There can be many spanning trees. Minimum spanning tree. In the spanning tree, minimum spanning tree is the spanning tree where the cost minimum among the spanning tree. There also can be many minimum spanning tree. The minimum spanning tree has direct applications in the design of the network. Here we have some applications, practical applications based on the minimum spanning tree. The first one is cluster analysis. The next one is handwriting recognitions. The third one is image segmentation. So this is an example for the minimum spanning tree. The first one is undirected graph. The next one is spanning tree. The last one is minimum spanning tree. So the next concept is Kruskal's algorithm. Kruskal's algorithm builds the spanning tree by adding edges one by one into a growing spanning tree. Kruskal's algorithm follows greedy approach as in each iteration. If it finds an edge which has a least weight and add it to the growing spanning tree. We have algorithm steps. Sort the graph edges with respect to their weights. Start adding edges to the mean sum of square tree, minimum spanning tree, from the edges with the smallest weights until the edge of the largest weights. So these are the examples. In Kruskal's algorithm, at each iteration, we will select the edge with the lowest weight. So we will start the lowest weight lower weightage first. That is the edge with weight 1. After that, we will select the second lowest weight. That is 8 edge with weight 2. In the similar way, we have to find the minimum spanning tree. So in general, from the Kruskal's algorithm, we can find the minimum spanning tree. So based on the procedure to find the minimum spanning tree, here we can use, or we can draw the rough spanning tree. Based on this, here we can find the minimum spanning tree. And also here we can find the minimum spanning tree with the total cost from the given question or given problem. Okay, this is enough. Thank you. Thank you for watching. Thank you very much.